Hello, grade 8. Our physics lesson is about mechanical energy. Mechanical energy. A system possesses energy if it performs or is capable of performing work. A compressed spring is used to eject a block along an inclined table. The compressed spring is capable of performing work because it is capable of ejecting the block onto the inclined table. It possesses energy before ejecting the block because it was able to perform work. A body possesses energy due to its motion or position. Kinetic energy. Kinetic energy is the energy a body possesses due to its motion. In situation 1, the truck is at rest. It cannot break the wall. The truck doesn't possess kinetic energy since it is at rest, therefore its speed is null. A truck at rest does not possess kinetic energy. Observe situations 2 and 3 where the truck is in motion. In situation 3, the damages caused by the impact between the truck and the wall are greater because the truck's mass in this case is greater. Now observe situations 3 and 4. In situation 4, the damages caused by the impact between the truck and the wall are greater because the truck's speed is greater. The kinetic energy of the truck increases as its speed and mass increase. Potential energy. Potential energy is the energy possessed or stored by a body due to its position relative to others. This energy tends to move the body from its position when left. For instance, when lifting a ball, it acquires a potential energy known as gravitational potential energy, which only becomes apparent when the ball is launched. Gravitational potential energy. A ball is dropped without initial velocity from point O, situated at a height h from the ground. The ball falls under the action of the gravitational force exerted by Earth. The ball doesn't possess kinetic energy at point O because its initial velocity at point O is zero. When we leave the ball, it moves. The energy acquired by the ball is stored energy caused by gravity. Earth conveys energy to the ball called gravitational potential energy. The gravitational potential energy GPE of a body of mass m is the energy it possesses due to altitude h with respect to the ground. GPE is equal to m times g times h, where g is the gravitational acceleration equals 9.81 Newton per kilogram. In SI unit, GPE is expressed in joule, m in kilogram, g in Newton per kilogram, and h in meter. Elastic potential energy. A compressed elastic spring launches a cart on a horizontal support. The energy provided by the spring to the cart is due to the elasticity of the spring or to the compression of the elastic spring. This potential energy is called elastic potential energy. The compressed spring stores elastic potential energy that is transferred to the cart. Magnetic potential energy. A piece of iron is initially at rest on a horizontal table. When left to itself, the block moves towards the magnet. The energy conveyed by the magnet to this piece is due to the magnetic force exerted by the magnet. This potential energy is called magnetic potential energy. The magnet conveys to the piece of iron a magnetic potential energy. Electric potential energy. A metal ball of negative charge is approached to a positively charged glass rod. When we leave the ball, it moves towards the rod. The energy conveyed by the rod to the ball is due to the electric force exerted by the rod. This potential energy is called electric potential energy. The charged rod conveys electric potential energy to the ball. Mechanical energy. The mechanical energy ME of a body at a given instant is the sum of its kinetic energy KE and its gravitational potential energy GPE at this instant. Mechanical energy equals kinetic energy plus gravitational potential energy. Conservation of mechanical energy. A cart is released without initial speed from position 1. Friction during motion is neglected. The cart possesses gravitational potential energy in position 1, kinetic energy in position 3, kinetic and gravitational energies in positions 2 and 4. Let's complete the following table and find the mechanical energy for each position. For the 4 positions, the mechanical energy is equal to 12 joules. In the absence of friction, the mechanical energy of the cart remains constant over time. In the cases where friction exists, part of the mechanical energy is converted into heat. That's it for now. Thank you for watching.